Hello YouTube. So today we're going to be solving the two-sum problem, which is given an array of integers and a target number target. Return the indices of two numbers such that they add to the target. So the examples we have are 2, 7, 11, 15, 2 and 7 add up to 9, and the indices of 2 and 7 are 0, 1. So another example, 3, 2, 4, we want to return 1, 2 because those are indices of 2 and 4, which add up to 6. 3, 3, 0 and 1 add up to 6 because 3 and 3 add up to 6. So only one valid answer exists, so we can assume that the first answer we get is the one we want to return, and there's not going to be any other one in the given numbers. So the first most naive solution you want to think of this is, you don't really want to think of it, but the obvious one is go through every single pair of two numbers, add them up, does it equal target? The way you do that is two for loops. You basically go through nums twice, compare each pair of numbers, and if it adds up to the target, return it. So I'll just write down that, even though it's not ideal. Nums.length I++, for int j equals I. You can make a little bit of a fix by starting with I, because you never need to look behind I, because you'll already have done those calculations. J is less than nums.length j++. If nums I, you could start with I plus 1, honestly, because you're always going to be a 1 above the current number. So when it's 2, you want to start with 7. Nums I plus nums j is equal to target, return new int of I comma j, and then you still need to, is there a bracket error somewhere here? It looks fine. Ish? Oh yeah, there is. Okay. Yeah, so go back here. You always want to return something, even if it's not, like if it's not found in the if statement, you try to return 0, 0, for example. Run code. And like this will work. It's a very naive solution. Gonna go back and think of a better solution. So the better solution you could do, one of them is sort the numbers in n log n time, and then you can theoretically put like two pointers, and you know that it's sorted, so you can always like add and subtract, and that'll be n log n time instead of O of n squared, for example. But that's a very complicated solution compared to what you could do by just using some memory. And what that is using a hash map. So the idea is you want to create a hash map. You want to put in each number and its current index. And then when you check a new number, you'll check if the hash map includes the target minus the current number. So, for example, with 2, 7, 11, 15, and 9 is the target. So when you go through 2, you're going to set the hash map to have 2, 1. No, you're going to set the hash map to have the number 2, 0, which is the index. And then when you go to 7, you're going to check, does the map include n minus 7, which is 2? And it does. So what you're going to do is you're going to return the current index you add for 7, as well as the index of 2, which is 0. So you're going to get 0, 2. So just to write that solution out, first we're going to want a hash map generally. So we'll just put in a double integer hash map. Integer list equals new hash map. That's that syntax. Oh, yeah, I'm just gonna take off that not comment right there. Cool. And then For int I equals 0, I is less than nums.length, I plus plus. If list dot contains key, so if you have a key with the value of target minus nums I, then you're going to do return new int list dot get target minus nums I. So you're going to be getting the index of the first value, and then you're going to be using the index of your current value. And then whether or not you find it, if you find it, you'll return. If not, you want to do a list dot put the current value with the current index. And if you don't find it, which shouldn't be a scenario in our case, but we're just going to add it just so the compiler doesn't give an error. Return 0, 0. Let's check if that worked. Compile error, hash map cannot be applied to type. List.get. Oh, wait. List.get. Oh, okay. There was a parentheses. Oh, yeah. This should be. Okay. Yeah. There's just a parentheses error there. Cool. So this returns 0, 1. I'm going to submit this. I have, from a couple of months ago, I did a couple of these. So this is 1 millisecond faster than 99.7%. Memory usage is less than 40%. I was going for speed with this one. If you go the sorting method or maybe the double for loop, theoretically your memory usage will be less, but like in most cases, especially in interview cases, you want to consider the time complexity over the memory unless they explicitly ask you to not create any objects. So that's that solution. I'd love to hear any feedback. This is my first video. I'm going to be going through a lot of the LeetCode. If you want me to be more energetic or more talkative or more descriptive or go through the examples, if you wanted me to go through the sorting example, I could have done that. I'd love to just go in the comments, click the like button. Thanks. See ya.